Okay, chalo. Yesterday we have done how to calculate the center of mass for the removed parts. Ona?
Yes, sir.
Let us try to go some important conclusions, beta. First one. Now see here, you know that acceleration of center of mass is equals to, I write this one as m1a1 plus of your m2a2 divided by m1 plus of your m2.
Yes.
అవునా కదా? Or else I can even write this one as m1 into force acting on that particle is F divided by your m1 plus this one is your m2 into force divided by your m2 divided by total mass m1 plus of your m2. Then what will be the acceleration of center of mass? Can you tell me? This m1 gets cancelled. This m2 and this m2 will get cancelled. Remaining is
2F
nothing
by
but how much for me?
sir.
2f by your m1 plus of your m2.
Yes.
A1 I am taking it as of F by your m part of relation. If acceleration of center of mass, if external force is 0, then acceleration of center of mass is also 0. Hence, that means when there is no external force acting on the system, and if they are in the opposite direction. Right now, say for example, if this particle is in the opposite direction, I am taking here minus sign. One positive, one negative. Both one will get cancelled right now.
Yes.
So the net force will become how much? 0. Isn't it? That means if there is no external force acting on the system, if there is no external force, if there is no external force acting on system, acting on your system, then F external will always will be equal to, because F is nothing but what we take internal forces.
Yes.
Okay na?
Okay.
So that means I can make one conclusion for this one. Point number 1, very important you see. In absence of any external force, in absence of any external force, that means there is no external force at all. In absence of any external force, the acceleration of center of mass is equals to 0. Okay, irrespective of the individual accelerations, irrespective of what beta? Individual accelerations. అంటే
Yes.
individual particle కి individual accelerations ఉన్నాయి, కానీ net acceleration of the system
It
will
will be
become 0
zero.
if external 0 part of relation.
Okay.
That means if F external is equals to 0, if F external is equals to 0, acceleration of your center of mass is becoming for me 0. And we know the formula A is equals to dv by your dt. Acceleration is nothing but rate of change of velocity.
Yes.
Or else I can write acceleration of your center of mass is equals to your differentiation of your velocity of your center of mass divided by your dt. If ACM is 0, now tell me what happens. If ACM is equals to 0, that is this one is 0. The differentiation of your velocity dvcm divided by your dt is equals to 0. That means what? Differentiation of this one is 0 means VCM should be equal to how much? Constant.
Yes.
Velocity of center of mass will be equal to what? Constant. And if there is no external force acting on the center of mass, acceleration of the center of mass will no doubt will become 0, but velocity of the center of mass will become for me constant, because the constant unteni ఇది 0 అవుతుంది కదా.
Yes.
So velocity of the center of mass will become for me constant. This is the first conclusion which you need to remember. In the absence of any external force, irrespective of individual acceleration, and if external force is 0, acceleration of center of mass of the system is 0. If acceleration of center of mass of the system is 0, velocity of center of mass of the system will become for me what? Constant.
Yes.
You know?
Yes, sir.
Chalo. Next conclusion. Point 2. In absence of any external force, in the absence of any external force. The velocity of center of mass VCOM is what beta? Constant. Okay, that means if initially the center of mass is at rest, velocity of center of mass will always be equal to how much beta? 0.
Yes.
అంతే కదా? If initially the center of mass is at rest, the center of mass initially rest లోనే ఉంది, isn't it? That means that is velocity of center of mass will become for me 0. Okay, that means the velocity of center of mass will always remain 0. The velocity of center of mass will always remain 0 irrespective of individual velocities, irrespective of the individual velocity of particles, individual velocity of your particles. Okay, that means what?
Yes.
If initially VCM is V naught anko, it will always remain V naught.
We don't.
It will,
remind us.
yeah, it will always remain VCM is equals to V naught. ఎందుకంటే constant కదా.
Yes, sir.
అవునా కదా? So we know that velocity is what beta? dr by your dt, yeah?
80.
Isn't it? Or I can write here velocity of your center of mass is equals to differentiation of your center of mass of the position coordinate divided by your dt. If VCM is 0, if velocity of center of mass is 0, then differentiation of your RCM divided by your dt is equals to 0. That means what? Position of the particle is always remaining constant. Position of your center of mass should always remain for me constant irrespective of the individual velocities. This is a very important point for the competitive examinations. But the second conclusion, in the
Yes.
absence of any external force, if velocity of center of mass is constant, that means if initially the center of mass is at rest, then the velocity of center of mass will always remain to be your 0. అవునా కదా? నా ఒకవేళ
Yes.
ఇనిషియల్ సెంటర్ ఆఫ్ మాస్ V naught ఉందనుకో, then it will always remain for me V naught only. Okay, like say if VCM
Yes,
is
sir.
equal to 0 from this formula, if VCM is becoming 0 means the RCM is nothing but what? Position vector kada. So position of the center of mass should always remain for me constant part of relation. That is my second conclusion from the given condition, the center of mass. The third conclusion is that if initially center of mass is 0, if initially center of mass is at rest anko, okay, that is VCM bar is equals to 0 and external force is absent, and external force is absent, external force is absent, that is F external is equals to 0, then the location of center of mass will always be fixed. The location of center of mass is fixed. Okay, na?
Exactly.
Initially center of mass is at rest lo undanko, that is
Yes.
VCM is equals to 0 and external force is absent, and external force is absent, that is F external is equals to 0. F external is equals to 0. The location of the center of mass is always fixed. The center of mass of the location is always fixed from the given category. Okay, na?
Yes, sir.
Let us try to do one problem based on this one. Let's say we have got two particles of masses 2m and 3m. 2m and 3m are placed at a separation D on a smooth surface. on a smooth surface. They move towards each other due to mutual attractive force. Due to mutual attractive force, like a bar magnets. ఒక
Yes,
నార్త్
sir.
పోల్ ఒక సౌత్ పోల్ ఉందనుకోండి, ఈవెన్ దో ఇఫ్ ఇట్ ఇస్ ఫ్రిక్షన్ ఫోర్స్, బికాస్ ఆఫ్ దట్ ఇంటర్నల్ ఫోర్స్ దే విల్ బి ట్రైయింగ్ టు మీట్ కదా.
Yes, sir.
So now he is asking us to calculate, find number A, acceleration of center of mass. Number B, velocity of your center of mass. And number C, velocity of your center of mass when separation between them becomes d by 3 beta. When separation between particles becomes d by 3. Number C, at what distance from initial position, at what distance from your initial position of mass 2m, the particles collide. Okay, so read the question once again. We got two particles of masses 2m and 3m which have been placed at a separation of how much beta d, and they are kept on a smooth surface and they move towards each other due to the mutual attractive force. Mutual means internal forces beta. There is
Yes,
no
sir.
external
Right,
force
sir.
acting in the system. Then find the acceleration of this center of mass. What is an answer for the first question? See, there is no external force acting on the system.
Okay, then it's 0, sir.
Then 0 kada.
Yes, sir.
Isn't it? So F external is equals to 0. F external is equals to 0 kabatti acceleration of the center of mass will be equal to your 0.
0.
Clear?
Yes, sir.
Then we need to calculate right now for me what? Velocity. See, initially the particles are rest. That means their initial velocities are how much for me? 0.
0.
That means velocity of center of mass is also 0. Since external force is 0, velocity of center of mass is always constant kada. Since F external is equals to 0, velocity of center of mass ఎప్పుడు కూడా ఏమైపోతుంది?
Constant.
కాన్స్టెంట్. అవునా కదా. ఇనీషియల్ గా
Yes, sir.
ఏముండేదండి? ఇనీషియల్లీ both were at rest. అవునా కదా. Hence velocity will always be remain how much distance? Whether the separation is d by 2, d by 3, d by 4, anything, the velocity of center of mass will always become how much for me? 0.
Yes.
అంతే కదా నాన్న.
Yes, sir.
అంతే కదా. or confuse చేయడానికి
Sir.
ఇచ్చాడు. Effective force is 0, velocity of center of mass is also constant. Initially both the particles were at rest.
Yes, yes, sir.
Okay.
Then
Hence I can say velocity of center of mass is always 0. It is your always 0 whenever the separation becomes d by 2, maybe d by 3, anything, etc. Clear?
yes, sir.
ఎందుకని ఎక్స్టర్నల్ ఫోర్స్ 0 కదా. వెలాసిటీ ఆఫ్ సెంటర్ ఆఫ్ మాస్ కూడా కాన్స్టెంట్. ఇనిషియల్లీ వెలాసిటీ ఆఫ్ సెంటర్ ఆఫ్ మాస్ ఎంత ఉంది? బోత్ ఆఫ్ దెమ్ వెలాసిటీ ఆఫ్
rest
సెంటర్
is
ఆఫ్ మాస్
0.
ఎంత? v1 is equals to v2 is equals to 0 అయితే velocity of center of mass would also be equal to 0, but it is not
0,
depending
yes.
upon the separation between them.
Yes,
Okay na?
sir. Yes.
Then third one. So what is the third part of the question is asking right now there? At what distance from the initial position of the mass 2m the particles are being located? Now first locate the center of mass of the system beta. How do you locate? Locate the center of mass. How do you locate the center of mass beta? XCM. XCM is equals to your m1 x1 plus of your m2 x2 divided by m1 plus m2. అంతే కదా.
Yes, sir.
Like say initially this is your particle. This is mass of how much for me? 2m. and this is your mass of your how much? 3m.
3m.
Both of them are moving because of their internal forces. Okay. Separation between them is nothing but how much for me? D. Isn't this is the first position? This is the second position. Okay. And the surface is
Yes.
nothing but a pure smooth. Now for mass xcm, if I am writing, xcm is equals to, this will become for me 2m into, ఇది x coordinate kada, ఇది origin కూడా ఉంది,
Yes.
that is nothing but 0 plus 3m into, from 2m it is the distance of how much for me? D, divided by, this one is your 2m plus
2m
of
plus
your
3.
D. This will become how much for me? Everywhere m will get cancelled, this m will get cancelled. So this
Yes.
will become for me 3d divided by your 5. That means
Yes.
initial center of mass is how much for me? 3d by
3
your
divided.
5 part position. Since center of mass is at your rest, the position is always for me fixed beta. అంతే కదా?
Yes, sir.
See, since center of mass is at rest, అవునా కదా? So this position is always fixed. Its position is always fixed. ఈ పాయింట్ క్లియరా?
Yes, sir.
ఎందుకంటే velocity of center of mass is constant, acceleration of center of mass is equals to 0. Hence the center of mass will always be fixed. So hence a particle will meet at what position beta? Hence the particles will meet somewhere here at a distance. Hence the particles will meet at center of mass at a distance of how much beta? At a distance of 3d
3D
by
by
5
5.
from A. ఓకేనా? అంటే
Yes,
ఈ
sir.
రెండు పార్టికల్స్ ఉంటే, దిస్ ఈస్ పాయింట్ ఏ, దిస్ ఈస్ పాయింట్ బి, ఇది సెంటర్ ఆఫ్ మాస్. సో ఈ డిస్టెన్స్ ఎంత? 3d by 5. సో both the particles, as they are coming due to internal force, they will try to meet at these two positions.
Yes.
Center of mass is always at rest. The position of the center of mass is always remaining to be at your rest condition. Clear?
Yes,
Very
sir.
good question, beta. You need to practice this question twice because you need to apply a lot of concept in that one. When the center of mass is remaining constant, when it is becoming 0, what all conditions, you try to do it out once again, beta. Okay, na?
Okay.
You'll make one more question. Good question, beta. A 20 kg kid, is sitting in a 60 kg boat. In a 60 kg boat in a lake. In a lake. The distance of kid, from the bank, of a lake, is 20 meter. If kid moves 8 meters on the boat, 8 meters on the boat towards the bank, then find the distance of kid. Find the distance of your kid from the bank. The system is initially at rest. So try to understand the terminology of the question better. And there is no friction. Between boat and water. Okay. A 20 kg kid is sitting in a 60 kg boat in a lake. The distance of the kid from the bank of a lake is 20 meter. If kid moves 8 meter on the boat towards the bank, then find the distance of the kid from the bank. The system is initially at the rest and there is no friction between boat and as well as of your water. First, try to draw the diagram. A 20 kg kid is sitting in a 60 kg boat. So we are having a 60 kg boat like this. So in this one, a boy is sitting or a kid. A kid is sitting in a 60 kg boat. Mass of this one is 60 kg. And this is your kid of 20 kg. The distance of the kid from the bank of the lake is 20 meters. That means if this is your bank of the river and this is your water. Okay. The distance of the kid from the bank is how much, beta? 20 meters. If the kid moves 8 meters on the boat, okay, now kid is moving from here to here. That means if the kid is moving in the front direction, what happened to the boat? Boat will be moving in the backward direction.
Yes, sir.
So boat will try to drift in the backward direction. And the drift and the so I'm taking that drift as of your x. This person has been, or this kid has been moved how much distance, beta? 8 meters on this one. అవునా కదా, ఇక్కడ నుంచి ఇక్కడ వరకు 8 meters కి వచ్చాడు అంటే
Yes,
the
sir.
boat is moving in the backward direction by your x, and this is your origin or maybe your shore you can take, isn't it? Since the kid is moving 8 meters towards the bank, boat plus kid move by x away from the bank. ఇద్దరు కూడా
Yes, sir.
backward direction మూవ్ అవుతున్నాయా లేదా? So I can write that point here.
20 plus.
Yeah. So since kid moves 8 meter towards the bank, and boat plus kid అంతే కదా, ఇద్దరు ఒకటే దాంట్లో ఉన్నారు కాబట్టి
Yes.
boat plus of your kid move by your x away from the bank. Okay, so what is the distance of the boat with respect to the ground, beta? X kada.
Yes, sir.
And what is the distance of the kid with respect to the ground? 8 minus x.
Yes, sir.
With respect to ground, and if you are standing somewhere here and seeing, if he is moving 8 meters in the front direction, you say that this boat is moving 8 meters in the backward direction. With respect to what? With respect to ground. So I can say here distance of boat with respect to ground and the x. Then what is the distance of kid with respect to ground? ఎంత అవుతుంది? 8 minus x. అవునా కదా?
Sir, I didn't understand how it was.
See, if you are standing here and you are observing this one, you are on the ground kada.
Yes,
So if you
sir.
feel that this fellow is moving 8 meters in the front direction and this fellow, the boat is moving in the backward
Okay,
direction by
okay.
x.
Yes, sir.
So you see that this is moving x distance in the backward direction.
Yes.
This fellow is moving your 8
Forward.
minus of x in the forward direction.
Yes, sir.
అవునా కదా, with respect to your ground. So as there is no external force on the system, so I can write here m1 d1 will be equal to your m2 into your d2. Antena?
Yes, sir.
So this is nothing but of your 20 into d1 is nothing but 8 minus x, that is equals to 60 into this one is nothing but x. This is the mass of the kid and this is the mass of the boat. Okay, m1 is equals to mass of kid. ఎంత ఇచ్చాడు అది? 20 kg. m2 is equals to mass of boat, that is 60. So this simplify చేసుకో ఎంత వస్తుంది చూడు. So what is the distance of the kid from the lake అంటే ఎంత అవుతుంది? So this one is nothing but how much for me? 20 into 8. 160 minus of your 20 into your x is equals to 60 into your x. అంతేనా?
40. So 40,
How much?
4 is the answer. Sir.
ఎంత
X is equals to 4.
4 వస్తుందా చూడు.
So sir, okay, sorry.
160 minus 60 కదా ఇది 60 మన
Yes sir,
ఇది
yes sir.
minus
By
ఇక్కడ
mistake I
పెడితే
did minus. Yes sir, yes sir.
ఉమ్.
82 వస్తుంది sir.
X is equals to 2 meters. వచ్చిందా?
Yes.
That means what you got now in the boat displacement, yourself and boat have been moved by how much distance? X. X is how much we got right now? 2 meters. Then what is the distance of the kid from the bank, beta? So distance of the kid from bank. Distance of kid from the bank. From the bank of your lake is. ఎంత వచ్చింది? యాక్చువల్లీ ఎంత ఉంది? 20 మైనస్ ఇది ఎంత వెళ్ళింది? ముందుకు వచ్చాడు కాబట్టి మైనస్ ఎక్స్ ప్లస్ ఎంత? ఎక్స్ డిస్టెన్స్ ఇద్దరు కలిసి బ్యాక్ సైడ్ వెళ్ళారు, అంతే కదా?
Yes sir.
చూడు మరోసారి. దిస్ ఫెలో ఇస్ కమింగ్ 8 meters in the front direction. That means what you will be saying 8 20 minus 8 చెప్తావు కదా. ఇది యాక్చువల్లీ 20 meters ఉందన్న.
Yes sir, yes sir.
It is coming 8 meters in the front direction. So what will tell? 20 minus 8 is the distance of
20
that
minus
fellow or
8,
kid
yeah.
from this one. But boat and this fellow are also moving in the backward direction ga, simultaneous ga. Some distance
Yes.
by back side kuda vellaru kada, simultaneous ga. Avuna kada?
Yes sir.
So for that one what I can take right now here, 20 minus 8 plus x cheskuntunnanu. Avuna kada? Ante that will become for me how much? 20 minus 8 is how much for me? 12 plus x is nothing but 2. Ante he will be moving totally how much distance? 14 meters. Okay na?
Yes sir, got that.
So I hope you got a rough idea related to this one.
Yes.
Okay na? ఇప్పుడు ఈ క్వశ్చన్ నువ్వు ట్రై చేయి. A boy of mass 40 kg is standing at one end of the boat. Mass is equals to 80 kg. Of length 6 meter. Of length 6 meter in a river. Now the boy reaches to the other end of the boat. First of all, find the distance moved. Find the distance moved by the boat and the distance traveled by boy as seen from the bank of river. As seen from the bank of your river. Assume that the system is at rest and no friction between the boat and the water. చెప్తావా?
Yes.
Try it. A boy of mass 40 kg has been standing at one end of the boat of length enta 6 meter in a river. Now the boy reaches to the other end of the boat. Find the distance moved by the boat and the distance traveled by the boy as seen from the bank of the river. Assume that the system is at the rest. The moment the system is at rest means what, beta? External force will be zero. Acceleration
Zero,
ledana
yes.
kada ardham.
Yes.
Avuna kada? So assume the system is to be at rest and there is no frictional force between the road, between the boat and as well as of your water particulation. So if I
Yes.
draw the diagram for this one, this is your shore.
So from ground looks as if
From
the
ground means
boy
from the
has.
bank. Bank
Yes,
అనగానే
sir.
ఏంటి? గ్రౌండ్ అని అర్థం.
Yes.
అంతే కదా, బ్యాంక్ అంటే ఏంటి? నువ్వు ఇటు సైడ్ ఉన్నట్లే కదా అర్థము.
Yes.
అంటే యువర్
Actually, it
స్టాండింగ్
is
హియర్.
moving 6 plus x. No?
Yeah. So this will be your boat initial ga. This is your initial position of the boat. The man is standing in this one, and this is how much for me? 6 meters. Okay. When this man moves in the front direction, you know that boat will be drifting in the backward direction. Man and the
Yes.
boat, both of them will skid in the backward direction. So ముందు x calculate చేయాలి. x ఎలా calculate చేస్తాను ఇంతకు ముందు చెప్పాను నేను. m1 x1, that is nothing but of your m1 d1 is equals to your m2 into your d2. m1 ఎంత? 40
One is 40 kgs.
into this one is how much? 6. అంతేనా?
Yes. Sir.
That is equals to.
So
ఇంకోటి
it's
ఎంత?
80
40
kgs.
plus 80 ఇద్దరు కదా,
Okay. Yes. Sir.
isn't it? 40 plus 80 and it is moving by distance of your x.
Yes. Sir.
అంతేనా?
Yes. Sir.
Am I correct?
Yes. Sir.
Since the center of mass is fixed beta, the boy will try to move towards the left to keep the center of mass always to be your constant. So it
Yes.
moves towards the right by how much right now? X. అవునా కదా? సో ఇదంతా
Yes.
చూడ x ఇప్పుడు క్యాలిక్యులేట్ చేయి.
Sir, 2, sir.
సో x is equals to 2 meters. వచ్చిందా?
Yes.
Now what is the distance traveled by the boy as seen from the bank? Distance traveled by the boy as seen by or as seen from the bank, or we can say ground. How much? 6 minus x kada?
Yes. Sir.
That is 6 minus 2. That will be equal to 4 meters. అంతే కదా?
Yes. Sir.
Is it clear?
Yes. Sir.
So that is a way how do we get the problems related to your river and as well as of your boat problems better mostly. I hope you got rough idea related to this one. I'll send you
Yes,
today
sir.
the assignment on this one better. You please try to complete that assignments on your boat and the man problem. It's a chana important area and you need to concentrate a lot on this one.
Yes.
Okay na?
Sir, in college we started with Pappus theorem.
Pappus theorem start chesara?
Yes. Sir. Yes.
I'll do
sir.
it. Shifting ane Pappus theorem ante emi chepparu adi continuous body.
Yes. Sir.
Arc of a circle ki center of mass calculate చేయడం అవన్నీ చెప్పింది.
Yes.
చెప్పేస్తాను. ఒకవేళ ఈరోజు ఈవినింగ్ ఏమైనా ఆప్షన్ ఉంటే ఒకసారి క్లాస్కి రాను ఒకసారి, మరి అయిపోగొట్టేద్దాం.
ఏ టైం సార్?
లేట్ ఈవినింగ్స్ ఎనీ టైం 8 o'clock తర్వాత 8 to 9 అట్లా ఏమన్నా ఇఫ్ ఇట్ ఈస్ పాసిబుల్ ఫర్ యూ.
ఎస్ సార్.
8 to 9 ఒకసారి నాకు ఒక 1 hour ముందు టెక్స్ట్ చేసి దెన్ విల్ ట్రై టు మేక్ ఇట్ వన్ క్లాస్. So we'll keep the full stop for the center of mass Pappus theorem and the remaining applications of that one also. Okay na? నీ కాలేజ్ ఎప్పుడు నుంచి స్టార్ట్? ఇప్పుడు
యాక్చువల్గా అయితే నార్మల్ 8 కదా సార్, కానీ ఈరోజు ఫస్ట్ పీరియడ్ జువాలజీ షీ ఈస్ టేకింగ్ 1.5 hour ఎక్స్ట్రా బికాస్ half an hour extra she's taking because she missed one class.
Okay. Who is teaching zoology?
Gauri ma'am.
Okay, fine.
Yes.
No problem better then. Okay na?
Okay sir. Yes sir.
Today evening if it is there possibility, you just commit at 8 to 9. We'll try to keep the full stop for this topic then.
Okay sir.
Okay na? Chalo. Take care beta. Bye.